So the question is then, are all the gases in the atmosphere capable of, absorbing this infrared radiation? All right. Well, I think not. And the reason there's lots of reasons why we know not. There's been a lot of experiments, but one dramatic example is this example of Venus. Venus, of course, is closer to the sun than is Earth, but the atmospheric temperature for Venus, the average atmospheric temperature for Venus is 450 degrees Celsius. Now, the atmosphere of Venus is different than the atmosphere of Earth. The atmosphere of Venus is under greater pressure, which means there's a higher concentration of gas particles in the atmosphere of Venus, and those gases are 96% of their air, if you want to call it air, or atmosphere around Venus is made of carbon dioxide. Whereas Earth, the average temperature, global temperature, is 15 degrees Celsius, and we know that our atmosphere is 79% nitrogen and 20% oxygen. We just have a very small, on the order of parts per million concentration of carbon dioxide in our atmosphere. Now, Venus is closer to the sun, but if you just base what the temperature should be based on distance alone, Venus should be about 100 degrees Celsius and Earth should be about negative 18 degrees Celsius. All right, so we know that Venus is 350 degrees Celsius hotter than 100. That's about the boiling temperature of water. Earth is about 33 degrees warmer than it should be based on the distance. Now, if we didn't have, so obviously there's something about the atmosphere that's keeping us warmer, and it's a good thing, because if we didn't have our atmosphere trapping the heat, our temperature would be negative 18 degrees Celsius. Everything would be frozen. All right. So obviously carbon dioxide helps trap heat. This is not a new idea. In the 1800s and 1900s, scientists have already proposed this concept of hothouse gases, gases that are capable of trapping infrared radiation, trapping heat. And they warned, even back then, that too much carbon dioxide in the atmosphere could cause the global temperature to increase. Now, why at that time would they have been concerned about carbon dioxide? Well, that was right at the beginning of the Industrial Revolution, when the industrialized countries were burning a lot of coal and producing a lot of carbon dioxide. Okay, so we have this concept of the greenhouse effect. Now, the greenhouse effect is the process by which atmospheric gases trap and return a major portion of the heat radiated by the Earth. Okay, that's the greenhouse effect. So there's something about certain gases that will trap and return a major portion of the heat that is radiated by the Earth. It's absorbed from the sun by the Earth, and then radiated by the Earth, and then trapped by the atmosphere. Okay, so then since we have this greenhouse effect, it's not a solid piece of plastic or glass, it's a gas. So then a greenhouse gas then is a gas that is capable of absorbing infrared radiation. Okay, that's how we define a greenhouse gas, as a gas that's capable of absorbing infrared radiation. And as it turns out, obviously, some gases must be better than others at absorbing and trapping infrared radiation. Otherwise, knowing that our Earth's atmosphere is 80% nitrogen, yet we do not have the same temperature as Venus, then there must be some difference between the different gases in our atmosphere. All right, and the other thing that we need to consider as we're trying to understand, this whole concept of the greenhouse effect, what is a greenhouse gas, what is global warming, that is, has our global temperature been the same over all the time that we have data, been collecting data on the global temperature? And indeed, what we know is that the Earth's climate has changed over time. Right now, at this point, you should be familiar with the concept of a greenhouse gas, the fact that the gases in our atmosphere trap heat, but not too much heat. Now, next we're going to look at, how has the climate changed over time, and is there any correlation to the concentration of carbon dioxide in the atmosphere?